guys, this is Brian. While we're waiting on the next video from Ben, I went ahead and wired up the 6502 and wanted to get set up to really, kind of step through and get to know the 6502. So what I've done is I've taken a Raspberry Pi Zero and wired it up so that it can send data to it can control the 6502 as a programmer, and it can monitor the breadboard. So give you a little tour of how this is hooked up really quick. What we have, the data lines are coming into a 245 8-bit latch. As you might know, the Raspberry Pi is a 3.3 volt, has GPIO, and everything else here is 5 volts. So I'm using the 245 here to control the data coming in when programming, and also as a 3.3 volt to 5 volt level shifter. There's also a series of lines coming in from the Raspberry Pi back here, and this one's on all the time, wired up to be on output enabled all the time. So it drives the clock. Right now I'm using the Raspberry Pi as the clock. So yeah, the Raspberry Pi controls the reset pin, the clock. It can set the data, and it will monitor all the address lines, and also monitor the data coming out. So to monitor everything, I'm using this series of 4 parallel to serial shift registers. So these first 2 are the 16 address lines. The next one's for the data lines, and then this last 8 are for the various just monitoring various pins, such as the read, the read-write pin 34 is important to monitor, very important, and it'll also monitor the gives me feedback on the state of the clock, if it's high or low. Okay, and also on the board I have two memory chips. One is a ROM, and the other one is a RAM chip. I'm using them differently than the original schematic, and we'll get into that a little bit. I had to swap out the ROM chip that I got from Jinko. Wasn't working quite right. I think it's locked, and I'll get around to unlocking it. But I just threw in an 8K ROM that I had laying around. So yeah, I'll get some more details on that in just a bit. Okay, so and up here I have some control logic. Mainly, this is a 157, 2-line to 1-line control or selector. So this is used to switch between run mode and program mode. Okay, so let me show you the Python script. So I'll just use PuTTY to telnet into the Raspberry Pi. And just have a little simple interface here for talking to the 6502 and the rest. One of the main things I can do, is reset, run the reset process. And this is important because this will set which memory address I want to work with. So just put that in there, it'll run through. all of its initialization, and I'm sitting at the that address that I wanted, and it just shows what data is sitting there. It's T test. I can dump 10 bytes just to see what's in what's at those memory locations. And one big change I made was the ROM is wired up just like the SRAM. I can write to it. The program can write to it just as easily as the SRAM. Okay, yeah, so I can run through the memory and just to see what's there. This monitors the different flags, the read-write flag, L. This is just pooling the data while the clock is low. And the way that this works is based off of Ben's the no-op that he suggested. So this test memory block, I just set up the EA, the no-op, and then stick that in there whenever the 6502 is looking for a command, and it'll run through the 2 pulses. And then while the clock is low, I go in and read read the address and enable the 6502, or enable the memory chips to put the data on the bus, and I can read in the data. So, and I can pulse the CPU clock one at a time if I want to. I can set a data byte. That's like when you're really just troubleshooting or going 1 byte at a time, just testing the wiring out. I don't really use that too much anymore. Sometimes toggling the 245. That's this one down here, so I can do hit the but mainly now I just write small programs out to memory and then step through them using these here and to test mostly right now. So I'll show you a little bit of how I have this development environment set up. Use this Notepad++ and the Notepad++ FTP. So I do all the work out here. I don't use VI or Nano or any of those text editors that are in Linux. Anyway, just rather do it out here. Notepad++ is has some of the color coding, and so it's pretty nice to work out here. And then, so say if I wanted to make a change, I'll change this, reset, then you just save it. It'll upload to the Raspberry Pi. I have FTP server set up on the Raspberry Pi, and then it's just a matter of restarting the program. And those changes are there. So and I do the same thing for the test programs. So here's the default test machine language test program, and so to get that into memory, and I can write several programs, just put them in different places in memory, and while I if they're in ROM, of course they'll stay there. If they're in RAM, then they'll stay there as long as keep the power on. So to write that, first do a reset to whatever location I want to put the program, and since this will just load a 0 into the X, increase it twice, store that over into 2550, which by the way is the ROM, and then a couple no-ops at the end. And this is the machine code. And my Python will run through this until it sees the X's. So I just, it'll get rid of all the spaces and breaks and stuff like that. And so it's convenient to put the actual assembly down here, and so the Python script will run through this and put the machine language into memory. So let's try that out. So okay, and this just have this this one command defaults to that 6502 hex dump. So set that. Want to run it? Have to reset back. And then just use the step command to step through. And I just watched the monitor, and it's very verbose. Even for one address, I get the clock low and the clock high because I'm watching every little change right now during this stepping through the program part of this. And see here, it's doing a write to that 2550, and I just watch for the EAs to come up. That way I know I'm done. Stop stepping through, and so it's just the way it works. So now, so if this worked, I should be able to go over to this 2550. I'll back up a little bit, 2546. Reset, then I'll hit the test, and then okay, a little more. So there, 2550 has a 2, so that's program's working correctly. Let's see, I have another, okay, this program 4, try this one out. This one will load a 1 into the accumulator, and then store the accumulator in 2660, do a roll left, 2661, roll all the way down. So I put you can see up here, I put a couple of EAs. Now, for writing the assembly, I'm sure Ben will have some similar suggestion. I found this this website here, so you can type in some 6502 assembly. I'll reset it. That, put some no-ops at the bottom, and just for me. Compile, do a hex dump. Take the machine language and bring it over here, put it above the X. His puts the address, his address markers in there. I take that out, and it's ending. So that I can hit save, uploads, and flip over to here. I can do Now I'll do the Q as the right file, so I can pick any file I want to. So that's 6.5. Oops. Okay, so to run this program, so I'll reset this to, since these are writing to this 2600, I'll go to 2600. Q. Okay, so I wrote that. I'll go back to reset the address back to 2600. And then just step through. And I'll just, eventually I'll have a way to step through, just let the program run. But this is just a first version, so I'm happy just to have this thing step through one clock pulse at a time. It's doing, you can see it's doing all these writes. Then it comes back, runs the program, and it does another write, 2666. Right, and then, okay, so I got the EAs, so I know to stop. Okay, so go back to 2660 and take a look at the data. Okay, you can just kind of see the, this monitors the address 0 through 7, so do a do memory dump. Okay, so 660 is the one, and shift over to 48, 1248, and so that's working great. All right, so until get the VIA hooked up, and for all that fun stuff, it's fun enough just to run some programs and change some memory addresses, and to make sure all this is set up correctly before the next step. So okay, let me get into, I'll show you my modifications. Okay, so just as a reminder, okay, here's Ben's design. Yes, this is the ROM. Both the RAM and the ROM are hooked up, and the same as far as the address lines and the data lines. I did the same thing. Address line 15 runs the chip select, and again over here, he uses the clock with address line 15 to run the chip select. I did my chip selects based on the addresses only. I didn't include the clock. So we'll see if that gets me in trouble, but it seems like it's working pretty good so far. He has the ROM, the write enable is just turned off, and the output enable is always on, and he has the output enable tied to A14, so that's fine. So to be able to, and the write enable on the RAM, SRAM is tied to the read-write on the 6502. So I have to change this around quite a bit to to have these control lines be controlled off the Raspberry Pi. So I use the, I still have, okay, so I have, the A15 still goes through an inverter for, I'm going to the SRAM, he's going through the ROM. Doesn't matter, you can swap, you can have both, well, both chips are writable in this design. So I could have two ROM chips, two SRAM chips. What doesn't make any difference. Like I said, I had to get an 8K ROM just to get things working, but I used the 32K SRAM. So the SRAM is based on all the high addresses, the higher 32K. The ROM I have wired up so that both the address 15 and 14 have to be a 0, and when A13 is high, then the chip select, the ROM will be activated. To go between run mode and program mode is the 157, is what drives that. Just a reminder, 157 has the A side, B side. The Raspberry Pi controls the AV to say whether it's in run mode or program mode. G is always turned on, so we're always in one mode or the other. So that's just wired up to ground. Yeah. So like I said, the chip select is solely based on the address. So and then the write enable is enabled for both chips. Can when we're in run mode A, the write enable pins for both chips are driven by the read write from the 6502. When we're in program mode, the Raspberry Pi has control over when the rewrite or the write enable is pulled low to save the data. So that's in conjunction with the data coming in from the Raspberry Pi. Okay, so well, that's that. I can monitor what's going on, and it was a lot of fun. Really, stepping through all this and getting it wired up so far. Learned a lot about the 6502. Anyway, thanks for watching the video, and talk to you later.